Okay, hello class. Today we continue to chapter hypothesis test. Okay, so proceed to the first subtopic, Z test. Okay, what is Z test? Okay, you can refer to the note. You have Z test and test statistic. Okay, for Z test, you have three condition. Condition 1, condition 2 and condition 3. And then you are given the test statistic. Okay, so I explain for condition 1. Okay, if the sample is larger sample means the value of data n must be more or equal to 30. This is larger sample. Okay, and you must know the standard deviation for population. Okay, this is the symbol for standard deviation. Standard deviation for the population. With these two conditions and more than or equal to 30, and you have the standard deviation for population, so you must use the test statistic Z equal to X bar minus mu divide sigma, means standard deviation over square root n. Okay, this is for first condition. And continue to second condition. For the second condition, small sample. Small sample means your n must be less than 30. Is small sample. Okay. Plus, you must know the standard deviation for the population. Okay. Standard deviation for the population. Okay, so for this second condition, you also use the test statistic here. Z equal to X bar minus mu divide standard deviation over square root n. Okay, this is two condition for the test statistic here. Okay, next for condition number 3. Okay, number 3, larger sample means your n more than or equal to 30. This is larger sample. Okay, and S for sample. S for sample. Okay, S is standard deviation. Okay, means you need to use S for sample, standard deviation for sample. For this condition, the test statistic used is Z equal to X bar minus mu divide S. Okay, S because standard deviation for sample over square root n. Okay. Okay, next I show you how to write the hypothesis testing. Okay, for this Z test. Okay, so can refer to the note. For example, your hash O, hash null, means mu equal to 20. Okay, your hash 1, you have two conditions. Mu more than 20 or mu less than 20. Okay, To identify more than or less than, you may refer to the question. It mentioned in your question. Use more than or less than. But the HO must be equal. Okay. HO equal. Okay. I just give the example equal to 20. Okay. But in question, it given to you. Okay. The value. Okay. After you state the H0 and H1, H0 and H1, you continue to significant level. Okay, significant level is value given. Okay, it given to you alpha equal to 0.1. Okay, and this value also can different value. It given in your question also. Okay, so for example, the significant level alpha equal to 0.1. Okay. Okay, and then you must have critical value. Okay, what is critical value? Critical value is the value that you read from the table. Okay, what table? Okay, because this is the Z test, you must refer to the table Z. Table Z is the table of normal distribution. Okay, I will given you on chapter normal distribution. You must use this table. Same table. Okay, so critical value. Okay, how to find critical value? Okay, Z alpha equal to Z. Okay, the alpha given is 0.1 equal. Okay, so how to read 0.1 from table? Okay, this is different between this subtopic with chapter normal distribution. How to read 0.1 from this table is you find 0.1 in the table. Okay, so find 0.1 or approximate to 0.1. Okay, so you can find the value of 0.1. Okay, this one 0.11 0.1003. This is approximate to 0.1. Okay, so 0.1003 when you read the value is 1.2 and 8 here. Okay, I repeat again, you find the value 0.1, okay, in the table. So the approximate value to 0.1 is 0.1003. So 0.1003 when you read the value is 1.28 here. 1.28 is 0.1003. Okay, you take the value 1.28. Okay, and then you must give the symbol for the value because your H1 is more than, so the critical value must be positive value. Okay, so here this is for less than value. Critical value, okay, same, Z alpha, Z 0.1 equal to 1.28. Okay, because this is less than, so here is minus. Okay, take note here. More than, so positive, is less than, is negative. Okay, next I continue to the decision rule. Okay. For decision rule, you must state the statement reject hash null if Z calculate means you need to calculate after this or more than Z table. Z table means the value from critical value. More than. Why more than? Because H1 is more than. So this one more than. Here the decision rule also more than. Okay. But for this case, your decision rule reject hash null if Z calculate, okay, and Z table, okay. The symbol here is because less than, so here for your decision rule also less than here. Okay. Okay, next we continue to example 1. Okay. For example 1, okay, read carefully and then find the info from the question. Okay, example 1. Suppose we would like to determine if the typical amount spent per customer for a dinner at a new restaurant in town is more than RM20. A sample of 49 customers over a 3-week period was randomly selected and the average amount spent was RM32.60. Assume that the standard deviation is known to be RM2.50. Using 0.02 level of significance, would we conclude the typical amount spent per customer is more than RM20. Okay, now we need to find the value of N first. How many data given here? Okay, a sample of 49 customer. So your value of N equal to 49. Okay, so you must state 49 is more than 30. So 30 is larger sample. Okay. The average amount spent was RM32.60. Okay, a sample of 49 customers over a 3-week period was randomly selected and the average spend was RM32.60. Okay, this is the value of X bar. Okay, how to find the value of X bar? It mentioned from the sample. Okay, a sample of 49 customers over a 3-week period was randomly selected and the average amount spent was 32.60. This is the X bar. Okay, and then assume that the standard deviation is known to be 2.50. Okay, this is the standard deviation known from the population. Okay, this is the sigma standard deviation from the population is RM2.50. Okay, so means the standard deviation is known. Okay, with the N largest sample and non-standard deviation, you must choose the test statistic first. Okay, for this example, it's from condition number 1, largest sample, non-standard deviation. So the test statistic that you need to use is Z equal to X bar minus mu divide standard deviation over square root n. Okay. Okay, we start to write the hypothesis testing H null and H1. Okay, using a 0.02 level of significance, we conclude the typical amount spent per customer is more than 20. So this is your O mu equal to 20 and H1 mu more than 20, because it mentioned amount spent per customer is more than 20. So the symbol here is more than. Okay, next you continue to the next step. You write the significant level given. So significant level given in this example is alpha equal to 0.02, and then you continue to test statistic. Okay, so in this case you must use X Z equal to X bar minus mu over sigma standard deviation over n. Okay, substitute the value for the X bar is 32.60 and your mu is here minus 20. Okay, divide your standard deviation given is 2.50. Okay, divide square root, your n is 49. Okay, and then calculate the value. Okay, the final answer for the Z value is 7.28. Okay, next we continue to critical value, the next step. Okay, critical value equal to Z alpha. Okay, Z alpha is Z 0.02. Okay, now you need to read the value 0.02 from your table. Okay, find 0.02 from the table or approximate to 0.02. Okay, so here 0.0202, this is approximate to 0.02. Okay, so the value is 2.05. Okay, so 2.05, but you need to write the symbol for critical value here. This is more than, so here must be positive 2.05 for the value of critical value. Okay, next we continue to the decision rule. Okay, the decision rule. Okay. Okay, what is the decision rule? The decision rule is reject H null if Z calculate more than. Why more than? Because the H1 is more than Z table. Okay, and then after the decision rule, you write the decision. Decision means you compare the value of test statistic and the value of critical value. Okay, so the value for your Z statistic means the Z calculate is 7.28 and the critical value is positive 2.05. You compare the value. So 7.28 is more than 2.05. So reject if more than. So the decision here is you reject hash null. Okay, so after you done reject hash null, you make a conclusion for this situation. Okay, what is the conclusion here? Okay, the question asks you, would we conclude the typical amount spent per customer is more than RM20? So the conclusion is there is sufficient evidence to conclude that the typical amount spent per customer is more than RM20. Okay, this is for example 1. Okay, next we continue to example 2. Okay, for example 2, first find the value of n and the standard deviation. Okay, because we need to identify the suitable test statistic. Okay, so from this example, in a random sample of 35, so your n equal to 35. Okay, 35 is more than 30, is larger sample. Okay, the sample mean time was 14.3 minutes. Okay, so this is your X bar, 14.3. Assume the standard deviation is known to be 5 minutes. Okay, so this is standard deviation for population, known as equal to 5 minutes. Okay, so this is from population. Okay, so with the condition and larger sample and you have known the standard deviation for population, so your test statistic you must use Z equal to X bar minus mu over sigma divide square root n. Okay, next we continue to find the HO and H1. Okay, using a 0.05 level of significance is the sufficient evidence to conclude that the average evening long distance call has decreased. Okay, has decreased means less than. Okay, so you state the mu here, the mean here. Okay, the mean for the average evening long distance is 15.2. Okay, so mu equal to 15.2 and has decreased. Okay, so decrease means less than 15.2. Okay, then you state the significant level. Okay, significant level, it given your alpha equal to 0.05. Okay, and then test statistic. Okay, test statistic is here z equal to x bar minus mu over sigma divide square root n. Okay, so substitute the value. Your x bar is 14.3 minus 15.2 and then you divide the sigma is 5 over square root n is 35. So your test statistic equal to negative 1.06. Negative 1.06. Okay, then after find the statistic, continue to the next step, find the critical value. Okay, for this situation, the critical value is z alpha. So z 0.05. Okay, so need to find the value 0.05 in the table here. Okay, find 0.05. Okay, when you refer to the table, 0.05 approximate to 0.0505 and 0.0595. Why? Because the two different is same. For 0.0505, the value is 1.64. And for 0.0495, the value is 1.65. These two value is approximate to 0.05. The difference is same, so you must take these two value. Okay, and then how to do? 1.64 plus 1.65, you divide 2. Okay, so the value for the z 0.005 is 1.645. Okay, and then don't forget to give the symbol for your critical value here, because the H1 is less than, so your critical value here is negative 1.645. Okay, next we continue to the next step is find the decision rule. Okay, the decision rule: reject H null if Z calculate Z table. Okay, what is the symbol here? Because the H1 is less than, so your decision rule also less than here. Okay, and then we make a decision here. Decision means you compare the value of test statistic and the value from critical value. Okay, so the Z calculate from test statistic is negative 1.06, and from Z table critical value here is negative 1.645. Okay, compare the value. Is it more than or less than? Negative 1.06 is more than negative 1.645. Okay, so do not reject because it's more than. Do not reject H null. Okay, so when you do not reject H null, what is the conclusion? Okay, so the conclusion is so there is no sufficient evidence to conclude that the average evening long distance call has decreased. Okay, do not reject means no sufficient evidence. If you reject means there is sufficient. Okay, so we finish for example 2. Okay, next we continue to example 3. Okay, same. You need to find the condition of this example, the situation. Okay, a random sample of 36. Okay, so the n is 36, means more than 30 is the larger sample. Okay, has mean life of 745 hours. Okay, so this is the S bar, 745 hours. Okay, with a standard deviation. Okay, when you read this sentence, a random sample of 36 light has a mean of 745 hours with a standard deviation. So this is S, standard deviation from sample 36, not sigma. This is S from sample, standard deviation from sample. So the standard deviation from sample is 60. Okay, so you have larger sample and non-standard deviation for sample. So your test statistic here equal to Z X bar minus mu over, this one is S, not sigma, S over square root n. Okay, next we continue to find the H null and H1. Okay, using a 0.01 level of significance, is there sufficient evidence to conclude that the mean life of certain type of light is more than 750? Okay, so your H null is mu equal to 750, so your H1 is mu more than 750. And then you continue to the next step is state the significant level given. This is alpha equal to using 0.01. So 0.01. Okay. Next. Continue to the test statistic. Okay, so the test statistic use here Z equal to X bar minus mu over S divide square root n. Your X bar is 745. 745 minus mu. My mu is 750 divide S is 60 over square root 36. So the answer for test statistic equal to negative 0.5. Okay, then we continue to critical value. Okay, so critical value. Okay, for critical value means you need to find Z alpha. So Z 0.01. Okay, read from the table normal distribution. Okay, so 0.01 approximate to, okay, 0.01 approximate to 0.0099. So 0.0099 is 2.33. So your answer is 2.33. And the symbol here, because this is more than, so here is positive value 2.33. Okay, next your decision rule. Okay, what is the decision rule? Reject H null if Z calculate Z table here. Okay, so more than, you reject if more than also here, the decision rule. Okay, then you continue to the next step, find the decision. Okay, you compare the value, decision. Okay, the value when you calculate using test statistic is negative 0.5. Okay, and from critical value is positive 2.33. Compare the value less than or more than. So this is less than. So do not reject. Reject if more than. Your answer is less than. So do not reject H null. H0. Okay. Then what is the conclusion? Because you do not reject, so there is no sufficient evidence. Okay. There is no sufficient evidence to conclude that the mean life of a certain type of light is more than 750 hours. Okay, so finish for example 3. Okay, for example 4 and 5, I want you try by yourself 4 and 5. Okay, that's all for this subtopic. Okay, thank you class. I will given the answer for example 4 and example 5 later, but try first. Okay, thank you.